All right, here we go for Unit 4, the information about doing limits. So you're going to have a graph, you're going to have to identify some, and you're going to have to identify or create a graph from the information. All right, so remember, you're looking for what the number is approaching from a certain direction. Now, what is it exactly, but what is it going towards? So on the first one, when I look at x going towards negative infinity, my x values are going out here, and the graph is going down as I go out, so negative infinity. As the limit is x is approaching -3 on the left. So -3 is right there. The left side is right about here, and so I'm following the graph up on that side. So I'm going up towards positive infinity. -3 on the right side. -3, what's the graph approaching on the right side of it? We got 1, 2, 3, 4, 5, 6, -6. So when I have the left and the right, if they are matching up, that was the limit of it. Otherwise, it does not exist. The limit does not exist. Okay. And then as the limit, as x approaches positive infinity, we go out to the right, points positive infinity, the graph goes up to 1, 2, 3, 4, 5. All right, so be able to sketch a graph means you make it. So when x approaches positive or negative infinity, and you get a value such as this, you have a horizontal asymptote. When x approaches a value and y approaches x infinity, so these are reversed, you have a vertical asymptote. And when x approaches a value and y approaches a value such as this, we have a open circle but a value. All right, being able to calculate some limits. So, be able to calculate a limit of the polynomial function. When you have information like this, no fractions, nothing to worry about, and just a number, plug in the value. So, -2 cubed minus 2 times -2 plus 6. You should end up with +2. Alright, when trying to make the limit of a rational function at a value that does not make the function undefined. So I mean the 0 on bottom. That's the problem spot. Again, plug in x. Okay, so what I'm looking for is concerned is if the denominator is going to be 0. If it's not, great. So we have 4 over -4, so -1. So that's when it does not make 0. I'm trying to find the limit of a rational function at a value that makes the function undefined. We always try to factor first. Try to factor. So always try to factor. See if you can cancel. So in this one, if I plugged in a -2, I'd have a 0 on the bottom, which is no good. So I'm going to factor x and x plus 2 plus 3 over x plus 2. Now these would cancel out, which would make my whole, but that's okay. So the limit is x is approaching -2, means I'm just going to take the -2 and plug it in for this and only this, so we don't need to worry about it. So -2 plus 3. You get a +1. Alright, so the next one is when we have to do the left and right side. So if it comes up as an undefined value in a rational function, which means a fraction over a fraction. So if I plug it into -2, okay, so if I'm plugging in, I get a -2, so it makes it undefined. Check the left and right sides. Infinity. Okay, so you're going to have a vertical asymptote at that number. You plug it in and it makes it 0. So really, I want to figure out what's happening very close to it. So like -2.1 and then -1.9. plug it into my function, I have a negative over a negative, so I have it's going up. When I have this one, I have a negative 1.9, I plug it in, I give a negative over a positive, so it means it's going down. So if they're going different directions, does not exist. Alright, the last group of what we've done is plugging in when you have infinite values to plug in. So when the top is smaller, you plug in infinity, and we're really looking at the exponents. When the value on top, you plug it in, it would be infinity plus 6, and then infinity squared minus 2. The top is smaller, the bottom is bigger. That means I'm going to go towards 0. When the tops and bottoms are the same, so we're looking at the degree, it's really take the coefficient, take the leading coefficients of both. So just like that, so 2/3. And then what's the other way around, when it's infinity, bigger infinity on top, so a bigger value on top and a smaller one on bottom, check the positive and negative signs. Okay, so if I plugged in an infinity positive, positive, so I'd have a positive infinity, or a positive minus 2, so positive, so I'd have a positive infinity. And that's it.